What's up, calculus students? Let's do the lesson one homework. We're talking about area between curves. We have thought of integrals for a long time as just being an accumulation. And we would just say, like, accumulate R, and you'd get the area under R from A to B. If we accumulate R and we subtract the accumulation of H, we are going to get the area shaded in yellow. But I want us to change our perspective. Even though this is correct, it's not the way I want you to do things for purposes of the next couple of lessons. Instead, what I want you to do is think about the accumulation as being a sum. And it's a sum of rectangles' areas where you actually have a height and a width. This is a rectangle. It doesn't look like one. Maybe I'll draw one just to be very clear. This is a rectangle. It is one representative rectangle of the infinite amount of rectangles that we want to sum up the areas of. What we're going to do is think about this one rectangle, its height, and its width. Now we're going to start with the width. The width is an x distance, and we're used to this from like our Riemann sum unit. But if we take an infinite amount of these rectangles, each rectangle's width has to be very, very small. So we're talking about a very, very small x distance. This is why the width is dx. This is why we need dx, or else we're not going to get area. We're not even going to get a value. We're going to get infinity if we sum up these y values, an infinite amount of them. They have to have this skinny width. So dx is important. And then the height is this vertical distance. Now to find a vertical distance, you could just take two y coordinates and subtract them. So if this is, say, a y distance of 3 and this is a y distance of 1, subtract them, you get the height of 2. Now that's just one example, but for all of my rectangles, the height is a y equals top coordinate minus a y equals bottom coordinate. So that's what I'm going to do. The blue rectangle has a y equals this function y coordinate minus a y equals this function y coordinate. The width of our rectangles is this small x distance. To ensure that we are getting positive widths, we have positive heights by doing top minus bottom. To ensure we have positive widths, we will go from left to right. That way we're going in a positive x distance. So we will go from an x equals left to an x equals right. I should probably write it over here. Left is x equals a, right is x equals b. And this is kind of what I want you to do. I mean, this is not kind of, this is what I want you to do. This will help you tremendously as we progress through this unit. Y equals, x equals, x equals. Okay. Make sure we read the prompts. Sometimes they're going to say, hey, you don't have a calculator for this entire thing, which means you need to get all the way through evaluating the integral. Remember, if you were to evaluate this integral with a calculator, you would just type it in as you see it. No calculator, you have to take the antiderivative. They'll have a plus c, but you won't need it. Find your ending position minus your starting position to get your displacement of your antiderivative, which is equivalent to the accumulation of this. So you're ready to do either. Sometimes you're just going to be asked to write but not evaluate integrals. So we have the square root of x, that's this. We have x squared, that's this. We have this y equals 1. We have this x equals 1. We also have this x equals 0 is where we're kind of starting. So we see we have everything we need for regions 1, 2, and 3. Tops and bottoms, lefts and rights. For R1, we have a rectangle like this that fits in there, whose y equals top minus y equals bottom is y equals 1 minus y equals root x. The width is a small x distance. I'm going from an x equals left to an x equals right. That's this x and this x. It's not this y and that y. For R2, ry equals top minus y equals bottom. I'll draw a example rectangle there. It's an example of one of the infinite amount of rectangles we have. The y equals top is y equals root x. The y equals bottom is y equals x squared. Those are my y distances to get the height of the rectangle. The width is a small x distance. Again, I'm going from a x equals left to an x equals right. And for R3, looks like you don't have a bottom, but you do. It's y equals 0. Now, a lot of people will feel comfortable / I think it's helpful if you write y equals bottom is y equals 0. Now, you don't need it, obviously, but just help to keep that in your brain. Width is a small x distance, 0 to 1. We could evaluate all of these by taking the antiderivative and plugging in 0 and 1, or 1 then subtract 0 plugged in, but they don't ask you to do it, so don't do it. Okay, to the question of the day, which I could give you your calculator. Is splitting a region into 2 equal parts. So I want to split this region into 2 equal parts with an x equals k. Now, how do we do this? Well, we actually need to find this area. Let's say we have our calculator, so we can do it quickly. But if we didn't have a calculator, let's get the same answer. The area is going to be 1/3. 0 to 1 of x squared is going to give you 0.333 repeated. How do I know that? It's because I know that the antiderivative is 1/3 x cubed plus c. If I plug in 0 and 1, I'm just going to get that answer 1/3. So that's 1/3. Now, that means, and this is how we set up and do these problems, and it's very important to do this the right way and just to do it yourself a couple times to get used to it, that if I go from 0 to k of my top minus the bottom, I will get half of my area. That is half of my area 1/3. Great. This is an equation that's set up to solve, but how do we solve it? Well, we got to get rid of the integral by taking the antiderivative. You have to plug in k and 0. Now, this is where a lot of students have a lot of confusions because it looks like I don't really do anything and I just have 1/3 k cubed minus 0. It's like 1/3 x squared, x cubed. Did you change anything? Well, not really, but I did do what I needed to do, which is to plug in k and then plug in 0. Now we get something that we can solve actually by hand, or we could solve with a calculator. If I was going to do it by hand, which is not going to be able to be done often, you would multiply both sides by 3. You'd take the cube root of both sides, and you'd get the answer, the cubed root of 1/2, or 1/2 to the 1/3. Using your calculator, you'd graph y equals the left side and y equals the right side. Now it's like 1/3 k cubed. Oh, that's 1/3 x cubed. And when I graph it, I'm going to graph 1/3 x cubed. But I'm not graphing this. I'm graphing this after I plugged in k and 0. Just so happens when I plug in 0, I get 0. That's not always going to happen. So like we got to do the process of plugging in the values. X stands for a K. That is the X value, the X coordinate, where we are going to split this area in half. I'll find the intersection between the two graphs. And we get that the K coordinate, which is this X coordinate, is 0.7937, which turns out is the cubed root of a half. Okay. Cool. Now, what if the top and the bottom changes? If you looked at, say, this region right here, we can see the top and the bottom is y equals g of x minus y equals f of x. This is a little bit confusing because it's like g actually ends up being the top. That will ensure a positive height. Now, if I go to this region, if I do g of x minus f of x, I'm going to get the opposite of my height. I'm going to take the lower y coordinate and subtract the bigger y coordinate. I get a negative height. I want to make sure I have a positive height, so I have to change the top and the bottom. Y equals f of x minus y equals g of x. So if you want this area without an absolute value, you need two different integrals. If you did this as in like overall, you need like four integrals. If you're like, oh, accumulate g minus the accumulation of f, and then you had plus the accumulation of g from b to c minus the accumulation of g, or whatever. It's easier if you just have rectangles, heights and widths. From A to B, the height is a y equals top minus a y equals bottom. From an x equals left to an x equals right. I'm not going all the way to C because the top and bottom changes. Don't forget about the width, which is a small x distance, and then I need to add from B to C my new y equals top minus y equals bottom. Top is now f of x, y equals f of x. The bottom is y equals g of x. And this will be correct. Now, if you were to use an absolute value, what you find is that one minus the other, this is crazy. One of the y's minus the other y would give you a positive height or a negative height. To ensure heights were always going to be positive, you could just use an absolute value. Now, if you use an absolute value, whether you have g minus f or f minus g over the entire interval from A to C, this will ensure positive heights because of the absolute value. You could do f minus g, you could do g minus f. This will give you the exact same result as this split up. And this is the same idea. You just have to change, and I didn't give you letters, so I'm going to put it in. You got to go 0 to A to B, B to C. We're going to kind of just skip this. We'll just do it. 0 to A is top minus bottom times widths. A to B is top minus bottom times the widths. B to C is top minus bottom, which is F minus G times widths. Or if you're checking, go from 0 to C of either minus the other. Okay. Now, for the first couple examples, like for this example, You were given everything. You're given an x equals left, an x equals right, a y equals top, and a y equals bottom. What if you are not given everything? What if you're just given two equations? Well, the missing information is going to be the intersections of your graph. Now, how do I know how these graphs intersect? Well, the only way for an area to be enclosed by two graphs is for them to kind of cross over each other. We can't have a situation where this x squared minus 5 and this y equals 4x is like this because I don't have an enclosed area. You should know that x squared minus 5 is a parabola that opens upward, negative 4x, negative sloping line. Now, we can see from this what the y equals top and the y equals bottom is going to be for this rectangle. This looks like a line. It's a skinny rectangle. It's got a height. It's got a width. So the y equals top is y equals negative 4x. The y equals bottom is x squared minus 5. Now notice I'm subtracting the y equals bottom in parentheses so that I can distribute things correctly, and I actually subtract that y coordinate. The width is dx, great. But what the heck is the x equals left and the x equals right? This is where missing information can be found by finding the intersections. How do you find the intersections of two graphs without a calculator? Set the equations equal to each other. It's a quadratic. You need to move everything onto one side. Factor to solve. This turns into x plus a number times x plus a number. The two numbers need to add to get 4 and multiply to get negative 5. So it's going to be positive 5 and negative 1, which means they intersect at negative 5 and at 1 as your x equals left and your x equals right. Now, without a calculator, we're trying to find this answer. Guess what? We got to take an antiderivative. We got to do some work. Now, there's a lot of arithmetic, but it's going to be okay. You just got to go for it. What I'd probably recommend doing is rewriting things in a correct order so it makes sense to you when you're taking the antiderivative. So this is a negative x squared. This can be a positive 5. This is still negative 4x. We antiderive now. We find the change in the antiderivative, and away we go. I'm not going to simplify. We're going to think of this as being a free response question. Negative 5 cubed is negative 125. Negative 5 squared is 25. Negative 5 times 5 is negative 25. And like that's the answer. Okay? Don't worry about simplifying. Think of it as free response. Free response, your answers don't need to be simplified. I am going to type in this so that when I check, I can make sure I got the right answer. Now, here's one thing you should know. Area between curves, always positive. My answer should be positive. It is. It's a nice, easy answer. You want to check. You can just type the integral into your calculator. You want to make sure you get a positive answer, use an absolute value. You want to make sure you get things right, well, just do either minus the other. Watch, I'm going to flip up the top and the bottom. I'm going to put x squared minus 5 first. Then I'm going to subtract negative 4x as the bottom. These are actually negative heights, but the absolute value would make them positive heights. And I get the correct answer, 36. I don't know how my calculator got that so quickly, but they did. Cool. Without a calculator, let's do this one. So we got x squared minus 3x plus 3. We got y equals x. It's going to be enclosed here. We can see the y equals top minus the y equals bottom is seen as y equals x minus y equals x squared minus 3x plus 3. That's the height. versus the width, which is a small x distance. I need to find the x equals left and the x equals right. How I find that is by finding the intersections. Intersections set the equations equal to each other. I get x squared minus 4x plus 3. I get x minus 3, x minus 1, which means this intersection is at x equals 1, and this intersection is at x equals 3. So I'm going to go from 1 to 3, and I need to evaluate this without a calculator. This is a benefit to having one integral. If you can simplify things, that'll help. Watch, I will have negative x squareds. I'll subtract negative 3x's. That's adding 3x's to 1x, and that's 4x's. All of a sudden, that's going to be easier to do because I don't have to take the antiderivative of this and that. I have negative 1/3 x cubed plus 2x squared minus 3x as the antiderivative plus c. We will find the displacement of the antiderivative to find the accumulation of this function. I'll get 27 divided by 3, which is negative 9, plus 18 minus 9 plus c, minus negative 1/3 plus 2 minus 3. I'm going to go, the c's will go away. This is plus a c. C's will go away. This is actually easy to calculate because this is 0. We just have to worry about this, which is subtracting these values, which is adding a positive, negative, positive. I get 1 plus a third. That's 3/3 plus a third, which is 4/3. I think that's my answer, simplified. I'm going to double check. Either minus the other should get 4/3, and I do. Now, what if I give you a calculator? Well, again, with a calculator, I don't think I give you enough here, but we'll see. We are only given 2y equals. We need to identify the top and the bottom, and we need to find the intersections. Well, now, with a calculator, to do all of that, let's go ahead and graph. Graphing will help you. Now, we're going to have to probably adjust some windows here. Yeah, it's like it looks like there's nothing. Zooming in, I don't really recommend, but it actually could help. But here's the key. After you press zoom in on the region. It looks like I need to zoom in around here. Yeah, this tiny little sliver is what we're talking about. Let's just adjust our x's to be like maybe to 2. Heck, I can adjust it to 1. Yeah, zoom in so you can see the region. That's the region right there. It's very skinny. It's very tiny. You got the 4x plus 1. We have these two intersections there and there. Now, what we're going to see is something that we need to be careful of. We can see the top and the bottom. The top is actually the line. The bottom is the e to the 2x. But the x equals left and x equals right are the intersections. Well, this first intersection is going to confuse you. 3.02 e to the negative 14th. You have to be comfortable with knowing this is your calculator approximating the location of a 0. This is at x equals 0. How do you know that's 0? Well, times 10 to the negative 14th moves the decimal place over 14 times. That's 0. Think about plugging in 0, you get 1. Plugging in 0, you get 1. You got to be able to handle that. Now, for the other intersection, it's not going to be a nice number. But I'm going to write down that number once, and I'm going to call it A. I'm going to store that as A. I'm going to type in my integral from 0 to A. You actually store the first x value. That x value is so close to 0 that if you go from like A to B, you're going to get the correct answer. But like, you should know that it's 0. You get 1.884. We're going to need that later, so hold on to it. Don't round any of your decimals. Round your final answer. Let me just show you how it would work if you use that crazy number. I'm going to call it S as the start. Let's store x as S, the start. Watch, your integral from S to A will be the exact same as your integral from 0 to A. Okay, so you'll be safe if you do that, but like, don't do it. You're better than I'm not sure if this is going to work out. I feel like sine of 2x will not intersect x twice. So I might need to adjust this question a little bit. Well, you know what? It might zoom in. Oh, this is fun. It actually intersects at 2 locations, 3 locations. This is important to see. I need to adjust my y's a little bit up and down. Let's go to negative 1 to 1. I gotta adjust my x's. Might be going too far. This might be fun. There you go. Okay. 2 integrals from some value to what looks like 0. I need to have my top minus bottom be let's see, what's the top minus bottom? The top is the line, the bottom is the curve. So I'll have x minus sine of 2x. And then I'm going to add from 0 to wherever my ending value is, the top minus bottom, which will change if I wanted to double check. I could go from my start to the end, which I need to find, of the absolute value of either minus the other. Let's find those intersections. Okay, let's store that. And let's find a B. Also, you can label this as y1, y2. And if you want to do, you could do y2 minus y1. You could do y1 minus y2. There's your y equals top minus your y equals bottom. Since you already graphed it in y equals, you might as well use it. I forgot about that for the next one. I feel like it's going to be the positive 0.974 because of symmetry. Or B is the opposite of A. So watch using an integral y2 minus y1 plus, I'm probably going to double that, but whatever. Like I was saying, I could probably double that. And I get an answer 0.4207. We'll hold on to that answer. And if I wanted to, I could go, A to B of an absolute value of either minus the other. Cool. All right, now we want to split these regions in half. Okay, so here's the setup. We got to be cool with this. That there is a line, x equals k, such that if I accumulate my rectangles from 0 to k, here it's going to be a to k. This next one's going to be at 0 because it splits it in half. So don't. We'll do this one. How about that one? And this one. Okay. So we're splitting this one in half. We're splitting this one in half. Skip this one, split in half because it's not a question I'd ask you. It's gonna be at 0. So we got 4/3 as my answer. That means the integral from, and this is important, not 0 anymore. We started at 1. From 1 to x equals k will be half of my area, 2/3. Very important that you have that 1 and you understand why we're starting at 1. 1 to k, half of the area, top minus bottom, x squared minus 3x plus 3, which turns into negative x squared plus 4x minus 3, which I'm going to just put. Half of my area being 4/3, half of my 4/3. Okay. Super important. Solving this equation, we take the antiderivative. Both of these examples we're about to do are very good examples because we won't make the mistake, or if we make the mistake of thinking that we don't do anything, we just take the antiderivative and graph the antiderivative, that's wrong. We take the antiderivative, we plug in k. Okay, it's like, well, nothing happened. It's like, no, we're doing this and we're doing it correctly. And we plug in 1 and we subtract it. So this value is super important. This is the antiderivative at k. This is the antiderivative of 1. This equals 2/3. This is an equation I can't solve by hand. This is when we graph y equals the left side, y equals the right side. We find the intersection. The intersection that we're trying to find needs to be between 1 and 3. It might actually be at 2. Probably not. Some of the times, like when we split things in half, it actually gets split in half on the x value in the middle. I don't think that's going to be true here. So I'm going to replace k's with x's, but these x's represent k's. Zoom standard. Zoom fit doesn't really help us these days. Okay, looks like there's 3 intersections. Which one do we want? We want the one between 1 and 3. There's 1. There's 3. I want this one right there. I don't want that one. I don't want that one. I want the line that splits this region in half. That's got to be between 1 and 3. Second calc intersect. Enter, enter, enter. 2. There you go. Turns out this does get split nicely in half at the x value, which is in between. Now, again, x is representing k, which is going to be that line that splits in half. Cool. Worked out that way. I don't think the next one works out that way, but let's find out. We got the area. We split it in half. X equals k, splits it in half. Now, I do have 0 to start. So 0 to k of top minus bottom. 4x plus 1 was the top. E to the 2x is the bottom. Will have to equal half of my area. Now, I found my area earlier, so I got to go back and find it. This value cut in half. Don't round it. Use the entire thing. Save that value. Actually, I'm going to store this value as C, because I'm going to want to graph y equals C eventually. Okay? But what do I graph on the left side? Well, again, I have to take the antiderivative. Now, this is going to be tricky. Don't mess up. 2x squared plus x minus, what's the antiderivative of e to the 2x? Undo Vegas's derivative. There's Vegas. What starts in Vegas stays in Vegas. Undo the derivative. I'm going to put dot, dot, dots. That way you know stuff comes after it. Okay, now plug in k. Cool, cool. Plug in 0. Oh, you're going to get 0. No. You get 0 here. You get 0 here. You get minus 1/2 e to the 0. That is not 0. That is a half. So 2k squared plus k minus 1/2 e to the 2k plus a half minus a negative 1/2 e to the 0. That equals the 0.942 number. Now we have an equation we could solve. This is the 0.942 number. Here is the 2k squared plus k minus a half e to the 2k plus a half we're looking from 0 to I made a mistake. Somewhere between 0 and 0.628. What was the mistake I made? 4x, 2x squared, 1x, e to the 2x, 1/2 e to the 2x. 0.942, which is half of my area. My area 1.884. 2k squared plus k minus 1/2 e to the 2k minus a half becomes plus a half. And plus. I figured out what I did wrong. I typed this in wrong. 4 plus 1. It's 4x plus 1. I was wrong up here. This is not 1.884. This is 1.273. It's math. You got to be able to get the right answer. All of your answers should make sense. So splitting that in half means this is 0.636. Everything's going to look on that. At least I think it will. Store that as C. I don't know, man. Is it right there? No, it's like I'm missing. What am I doing wrong here? Oh, probably because I graphed it wrong. I didn't find the right intersection. Troubleshooting. Let's see. Did I graph this wrong? Did I graph? No, I don't think I did. 4x plus 1 e to the 2x. There's 4x plus 1. Here's e to the 2x. The intersection should be at 0.628. Okay. That's fine. What? I must not have typed it in wrong again. This area is actually 0.161. It's that small. That's crazy. That's crazy. I totally just mistyped things, which means divide that by 2. It's 0.080. Sorry for the delay, folks. Hopefully one of you got this right. And you're like, what is Mr. Master doing? This is garbage. Can we get a real teacher that knows what he's doing? But I guess this is just showing you like how you can troubleshoot things. Don't round. I stored it as C. I'm going to graph these. I'm going to unhide them so I can see them. I will be able to see that intersection right there. Oof, this is tough to see, but we'll find it. .33. 0.33 is in between 0 and 0.628. That's my K value, 0.330. All right, we got it. A couple more questions from old AP tests. These are like the free response types questions that you're going to see on your test, where the region's going to be given to you, which is nice. This is actually a no calculator question, which is a little bit annoying because if you set up your integral, your top minus bottom, you first of all have to notice that this is the top, this is that curve, and this is that curve. How do you kind of know it? You can kind of see the cosine curving downward then upward, versus this is just an opening downward. But here's an example of guys like, it's free response. Let's not get too intimidated about arithmetic. That's the top minus the bottom from an x equals left to an x equals right. Let's just take the antiderivative, plug in 2 and plug in 0, and leave it. Now you got to get the correct antiderivative, which is annoying. Gonna simplify a little bit. That 6 and that 2 is an 8. Okay, so I have an integral from 0 to 2 of 8 minus 2 x minus 1 squared plus negative 3 cos x over 2 pi over 2x dx. Now it's like, what the heck do I do with that antiderivative? Well, let's just talk about it. Antiderivative of 8x. This is a Vegas situation. Since the inside is just x, the derivative is just 1. The undone derivative isn't going to change anything. It's not going to create an x. We're not going to have any worries. Honestly, you could just take the antiderivative of the outside, undo that 3 that's going to come down, keep Vegas, and this is correct. Now this, cosine pi over 2x minus 3. You keep the minus 3. The antiderivative of negative cosine is negative sine. You have to undo the derivative of the inside. The derivative of the inside is a pi over 2. So that means you need a 2 over a pi, or divide by pi over 2. I'm just going to multiply by 2 over pi, get this, and plus c, 0 to 2. Here we go. What is it going to look like? 8 times 2 minus 2 thirds. 1 cubed. I'm going to go ahead and just know that 2 minus 1 is 1. And then I got negative 6 over pi. You're allowed to write sine of 0 and just leave it like that. Minus 0 minus 2 thirds. Let's say you're freaking out. You're like, I don't want to make any mistakes. Okay, minus 2 thirds, 0 minus 1 plus negative 6. Wait, I'm supposed to plug in 2. So that means this is pi, which is 0. I was thinking ahead. Minus 6 over pi sine of 0. This is your answer right here. Like, don't be intimidated by free response. Free response should be like welcoming because you don't have to simplify. All right. Write an equation for the line tangent of f at x equals 1/2. This is a good little review. Hey, review. Y minus y1 equals an m. X minus x1 at a half. One. Y minus 1 equals m. X minus a half. What's the slope? Well, get the slope equation. 24x squared. Plug in a half. It's a fourth. I get 6. All right, cool. That was fun. Just a little review. What's the area? No calculator, unfortunately, but let's be okay with it. Sum up from an x equals left to an x equals right. They're giving you the intersections. You don't have to find them. Of a y equals top minus a y equals bottom. Take the antiderivative. Okay, this is a Vegas situation. We got Vegas and its undone derivative. Negative cosine's derivative is sine. We got an x to the fourth, which means this needs to be a 2. We got a plus c, but it's not going to matter. Plug in a half as you see it. Plug in 0 as you see it. And you're good. This is correct. I have to accept this. The AP exam has to accept this. Okay, a couple more no calculator questions. Area of R. Okay, this is a good one. We look at this region a lot more in this unit. Top minus bottom. Y equals top minus y equals bottom. There's the y equals top. Here's the y equals bottom. From an x equals left to an x equals right. That's the height. Width is dx. Anti-derive. This is a 1/2 power. It becomes a 3/2 power. Multiplied by 2/3, this becomes a 4/3. Six times 9 minus 4/3. 9 to the 3/2. I have to accept that. That's the answer. Can it be simplified? Yes. 54 minus 36. Like it's a whole number. Like the square root of 9 is 3. 3 cubed is 27. Divided by 3 is 9. 9 times 4 is 36. 54 minus 36 is 18. But like, whatever. Look, they give you the intersection point. Like the free response questions that deal with these areas and eventually volumes, they try to make sure you're not making mistakes that'll really hurt you. Here's the x equals left. Here's the x equals right. Here's the y equals top minus the y equals bottom. X equals left to x equals right. Antiderive, because it's good practice. 4 minus 8/3 is the answer. Okay. All right, guys. It gets harder. It gets harder next lesson. We shift our our rectangles from being vertically oriented to horizontally oriented. We then place objects on top, and we're talking about volumes. It gets harder. So embrace the rectangle. I should have been drawing rectangles for every single question so you can see. Because once things change to going this way, everything changes. Our perspective has to change. So y equals top minus a y equals bottom gives me a y height. X equals left gives to an x equals right gives me a positive width. Widths being very small, skinny. Okay, embrace it. You'll be all right. Later.